Assalamu alaikum. It's a great pleasure and an honor for me to be here with you this evening. But you have to know that I'm here under a little bit of duress. And that duress stems from Solly. Because when he called me to invite me to speak here, you cannot say no to Solly. And Solly has been such a wonderful friend over many years. It's always an honor to be here at the MINARA Chamber of Commerce. So I prepared, in response to Solly and Fauzia's request, a talk on COVID-19. But I'm sure that, like me, you are fed up of COVID-19. And the last thing you want to hear this evening is somebody now tell you all about COVID-19 once again. So I have decided not to do my talk that I prepared, and that's on the slides that you see. So you can take down the slides. Instead, I'm going to use my time, given that this is an occasion to reward, to acknowledge, and to recognize excellence. I'm going to tell you a short story about excellence. It stems from 2003, when I was at my clinic out just beyond Howick in a place called Vullenledla. I have a research clinic there. We see about 1,000 patients a month there in our research clinic. And a young lady was at the clinic, and I was talking to her, and we enrolled her in one of our studies. Turned out that she was the 256th patient that we enrolled in our research. And so her code name is Caprisa 256. Now I'm telling you that because, remember it. It is going to come to you at some point in the future, probably in early 2025, when we get the results of the research that she is part of. This particular patient, Caprisa 256, was enrolled in our study when she was HIV negative. Unfortunately, she got infected. She got infected with the virus in 2005. We started seeing her, we put her on treatment when she qualified, and we've been following her, and to this day, she comes regularly to our clinic, and she is doing superbly well. When a person gets infected with HIV, as they do with any virus, they develop an antibody. Now, you're familiar with that. Antibodies are what we use to protect ourselves. And anyone who gets infected with HIV, automatically the body will produce an antibody. In HIV, the antibody against the virus is very specific. It will only kill the virus that caused the infection. It will not kill any other HIV. And HIV is in rapid evolution. So the HIV you get infected with, within a week, the virus has changed. You've seen that from COVID, how the virus changes from alpha to beta to delta, gamma and delta, Omicron. HIV is faster. It changes almost every 2 to 3 days. And so what happens is that the antibody that you have in your blood when you get infected, it can't kill the virus. It can't kill the virus that's in circulation because it only kills one virus, the one that infected you. In 2010, two groups in the US made an important discovery. And that discovery was that there are these rare individuals who make a very unusual antibody. And they called it broadly neutralizing antibodies. Suddenly we discovered that there were these special people who could make antibodies that killed a whole range of HIV. When we learned about that finding, one of the first things we did, we sent one of our students to the US to go and learn how to look for these patients. And we took thousands of our patients and we tested their blood to see if any of them had this very special antibody. And in that test that we did back in 2011, we took 400 HIV. We got the HIV from countries throughout the world. We had HIV, the virus from China. We had the virus from Australia, from all the countries in Africa, from Europe, from South America, from the US, from Canada. We had 400 different HIV. We added a small drop of her blood in each of the wells with these 400 different viruses. Caprisa 256, her blood kills 4 out of every 5 viruses. A special antibody. We noticed something unusual in her antibody, in that when we added very small quantities, she was killing large numbers of the virus. We knew something was very unusual about Caprisa 256. Now the problem is, we can't sit and bleed her all the time to get this antibody. So we have to solve that problem. So what do? We take a vial of her blood and we send a student of ours to the National Institute of Health's Vaccine Research Center in Washington, the USA. And we say to her, we want you to go and find the cell in her blood that makes this antibody. Now, I don't know how many of you remember high school biology. Now I'm going to take you back. You remember in blood, there's white cells, there's red cells, and there's platelets. Remember that from high school? Now, in your white cells, you have neutrophils, lymphocytes, basophils. You remember all? I'm really taxing you here. Well, it turns out that when you look at lymphocytes, there are 2 kinds of lymphocytes, T lymphocytes and B lymphocytes. A B lymphocyte makes antibody. And when a B lymphocyte makes one particular antibody, it will only make that antibody. So because we have so many antibodies in our blood, we have thousands of different B cells making each of those antibodies. So essentially, the B cell that makes this antibody in her blood, it's probably around 1 in 10,000 B cells. So when we sent the student, we knew she had almost no chance of finding it. How do you find 1 in 10,000 cells? It's a needle in a haystack. But we thought it was a useful exercise. She should try it. We gave her a stipend for 3 months. just before she was about to leave, I got the call. "I found the cell," she said. One cell, just one B cell that makes this particular antibody. That precious cell, we took it straight into our lab, we cloned it, we grew it in culture, and we were able to then make it produce the antibody. It took us 7 months to make 3 grams of antibody. You know what 3 grams looks like? You can't even see it. It's a little speck in your finger. We took those 3 grams of this antibody and we sent it in a vial to our friend Professor Dan Buruk at Harvard University. And we told Professor Buruk, please put it into the monkeys to see if it prevents infection. So he did that study for us. What he did was he did a blinded study. So he gave half the monkeys the actual Caprisa 256 antibody at different concentrations, and he gave the other half of the monkeys a placebo. And he doesn't know which monkey got the placebo, which monkey got the antibody. After he injects them, either with the fake or with the real antibody, he then challenges them with a monkey form of HIV. In doing that, all of the monkeys that got the placebo became infected, as you would expect. Every one of the monkeys that received Caprisa 256 never became infected. To this day, we have not been able to infect a monkey that has received Caprisa 256. Wow, we said, that's a great result. So we took that result, and Gracia and I flew to Bethesda to see Dr. Anthony Fauci, an old friend of ours. And we showed him this result, and we said, we need a partner, because we need to make this antibody to put it into humans to see if it can protect against HIV. He agreed, partnered with us, and put up the $20 million we needed to manufacture the first batches of this antibody. The vials were delivered to us in the midst of the COVID pandemic. We received them, we put them into humans, and we now are doing a study that will give us the answer as to whether this antibody works in humans to protect them against HIV. Essentially, if Caprisa 256 works in preventing HIV, it is a game changer. It means that we can provide those who are at highest risk, we can provide them with an injection once every 6 to 9 months, and that will then protect them from getting HIV. The whole idea is to move into the next step, which is to make a vaccine modeled on the antibody and to use the antibody to try and effect a cure. So we are a long way from all of that. We'll only know the results. We are doing the study right now. We have enrolled 820 women, high-risk young women, into the study. We will finally enroll just over 1,000, and we will observe them until 2025, and at that point we will have some idea as to whether this antibody works. This is a story of hope. This is a story about what it takes to do high-quality scientific research and what it means to be a world leader in developing completely new technologies in the field of HIV. I say that because I get inspiration every day that I'm in South Africa. I see people who, despite everything to oppress them, steal from them, make their life difficult, and yet they rise. Yet they will come forward. I saw that same spirit when I watched the rugby last week. And I hope I'm going to see that same spirit in the rugby tomorrow night. Thank you very much.